Hello guys, welcome to Java session. In today's session, we will discuss about exceptions. Topics are introduction to exceptions, exception hierarchy, user-defined exceptions, exception handling, the throw statement, the throws class, assertions. An exception is a problem that arises during the execution of a program. Okay, like if we have a set of statements and during the execution of those statements, we may encounter exceptions. Means we can have any type of problem that which stops the execution of our statements. So that is known as exception. When an exception occurs, the normal flow of the program is disrupted and the program terminates abnormally, which is not recommended. So therefore we need to handle those exceptions. So if we foresee any exceptions can arise during the execution of statements, then those exceptions we have to handle. Okay, an exception can occur for many different reasons, like a user has entered invalid data. Like if we have one screen, okay, where some calculations like some numbers are there and user can enter any type of data, so we cannot assume that user enters a particular data, so they can enter any type of data, so we need to handle those scenarios. So that is, so invalid data, if user enters, that needs to be handled by application. And also a file that needs to be opened and cannot be found, like if you are dealing with files. Okay, if you want to read some file from some file server, and if the file is not available, so then what should happen? So we need to handle such kind of exceptions. Okay, and also a network connection has been lost in the middle of communications. So if any network failure comes, then how to handle those situations through our program. And JVM has run out of memory. So these kind of reasons that can happen during the program executions. So these reasons we need to handle through our program. So some of these exceptions are caused by user error, others by program error, and others might be physical resources failure. So, by looking at these reasons, exceptions are categorized into three types. One is checked exceptions, and another one is unchecked exceptions, and finally errors. What does it mean by checked exception? A checked exception is an exception that occurs at compile time. These are also called compile time exceptions. Okay, these exceptions cannot simply be ignored at the time of compilation. The programmer should take care of these exceptions. That means, okay, when we write a program, a particular method can definitely throw an exception. So if we feel, okay, this particular method is handling with file operations, so there might be a chances of not having a file at file server. So that is checked exception. So we know, okay, there are some scenarios where exception can definitely occur. So those scenarios are known as, so that is, we need not to run a program. So when we write a program before compiling, we can come to know that a particular scenario can throw an exception. That exceptions, those exceptions are called as checked exceptions. And next one is unchecked exception. An unchecked exception is an exception that occurs at the time of execution. So I mean, like our application uh, runs well when user enters appropriate data. If user doesn't enter appropriate data, then we call it as, you know, unchecked exception. So we might not know, user can enter anything. So during if by, you know, entering invalid data, if you get an exception, that is not any checked exceptions. So those kind of exceptions are called as runtime exceptions. So these include programming bugs such as logical errors or improper use of an API. And these runtime exceptions are ignored by at the time of compilation exception. And finally, errors. These are not the exceptions at all, so but problems that arise beyond the control of the programmer. So neither file handling operation, either checked exceptions nor unchecked exceptions, like you So like if user doesn't enter appropriate data, uh, even that scenario doesn't cover under errors. So errors are typically ignored in code because we can rarely do anything about an error. So errors we cannot do anything. So what kind of exceptions that we call it as errors, like stack overflow errors. Okay, when error occurs, they are also ignored at the time of compilation. Like if out of memory, if we are creating n number of objects and memory is not sufficient, so JVM can throw out of memory error. So those kind of exceptions we call it as errors. Okay, so so this is the exception hierarchy. Okay, java.lang package, this is the base package. Under this java package object, okay, so this is object class, and under this lang package we have object class, and in this object throwable class is extends this object class. So and throwable is divided into two subclasses, one is errors and another one is exceptions. And exceptions is again divided into two types, runtime exceptions and other exceptions. So this is how we uh, you know divide these exceptions into multiple categories. Okay, and there are various methods available in these exception classes, like get message, okay, which is of type return type as string, which returns a detailed message of about the exception that occurred. And we have get cause method, which of return type throwable, which returns the cause of exception that is represented by throwable object. And we have toString method, which returns the name of the class concatenated with the result of get message. And print stack trace, so what it does is it prints the result of toString along with the stack trace to system.err error. Okay, and we have get stack trace, returns an array of containing each element on the stack trace. Like if I'm we have multiple methods, one method is being called by another method and another method is called by another method. So this hierarchy, if this exception is also propagated to different methods, so those returns an array containing each element of the stack trace. And also fill in stack trace fills the stack trace of a throwable object with the current stack trace, adding to a previous information stack trace. I'll show you like how these messages are available in throwable class in exception object. Okay, next one is user defined exceptions. So now we saw like there are default classes available in java.lang package. Okay, and not only these default classes, we can create our own exceptions. Okay, user defined exceptions are usually defined to provide fine grained categorization of error situations instead of using the existing exception classes with descriptive detailed message to differentiate between the situations. So suppose I'm developing one application. Okay, in that application if user enters invalid data, so I wanted to handle that particular exception. So instead of throwing a regular normal exception class, what I can do, I can create my own class which can have detailed message. Okay, user entered this information and this should not be like this. So we can these user defined exceptions or custom exception can either extend the exception class directly or one of its checked subclasses, thereby making new exception is checked. So these exceptions are known as checked exceptions or the runtime exception class to create a new unchecked exceptions. So the syntax of user defined exceptions is class my exception extends exception class. Okay, so we will see like I'll give you an example on custom exceptions as well. We'll go through how to handle this exception. After that we will see each and every these user defined exceptions as well as how to handle those exceptions. Okay, in a sample class. Next, exception handling. The mechanism of handling exceptions is embedded in the try catch finally constructors. Okay, which has the following general form. Like see, if 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 we have a set of statements and these statements may throw an exception. Okay, So if any set of statements that might throw an exception, then what we can do, we can put those statements in try catch block. Okay, we can put in try catch block. So any set of statements that are enclosed in a try catch block, okay, those statements, so if any exception arises, that will be handled by these catch statements, catch blocks. Okay, and so then our program will execute. Suppose if an exception arises in this, suppose if we have five statements, at statement 3 we got an exception. Okay, uh, and that will be handled in one of the catch block. Okay, suppose in this catch block we handled, and after that it can execute other statements if we have. So if we don't handle these statements, then what will happen? Suppose at statement 3 we got an exception, then system will not execute the other statements, it will terminate the program. So in order to continue our execution of statements, what we need to do is we need to enclose those statements in between try catch. Okay. So exceptions thrown during the execution of try block can be caught and handled in a catch block. A finally block is a guaranteed block to be executed regardless of cause of exit from try block or whether any catch block was executed. So suppose if exception occurred, okay, at a statement 3, then one of the catch exception type n, this got you know that exception got caught under this catch block, and these statements got executed, and afterwards what will happen, finally a statement will be executed. Even if any of these catch statements are not executed, if we don't have appropriate handling catch block, even that case also finally block will be executed. Okay, so try block, the try block establishes a context for exception handling. Termination of try block occurs as a result of encountering an exception. So what does it do? I mean, like if an exception occurs, then this try block will be terminated. Okay, even if successful execution of statements, then also try block will be terminated. The catch blocks are skipped for all normal exits. So catch block will not be executed if any exception if exception is not erased. Okay, when no exceptions were raised, then the catch blocks will not be executed and control is transferred to finally block. See here, execute block. If exception occurs, find the first matching catch block. Find the first catch block. No catch block found, then what it does, execute the finally block. If find the matching, if suppose catch block 1 found, then it will be executed and execute the finally block. Catch block, only an exit from a try block resulting from an exception can transfer control to catch block. So if any of so in execution of a set of statements, if exception arised, then control can go to the appropriate catch block. A catch block can only catch the thrown exception. So whatever the exception that has been thrown from those statements, those objects, if you are handling in the catch block, then control will transfer. Okay, exception is assignable to the parameter in the catch block. The code of the first such catch block is executed and all other catch blocks are ignored. Like if suppose we have arithmetic exception and exception class, okay, objects. So if any of these exception is arithmetic exception, then first catch block will be executed and remaining catch blocks will not execute. I'll show you in example. Okay, on exit from a catch block, normal execution continues unless there is a pending exception that has been thrown and not handled. So if any pending exception, suppose if are there any other exceptions that have been there pending, those exceptions will be handled in other catch blocks, otherwise it will terminate from the catch block, and finally if finally block we have, then that will be executed. Okay, and control is always transferred to the final block if one specified. And finally final block, if the try block is executed, then the finally block is guaranteed to be executed regardless of whether any catch block was executed. Since the finally block is always executed before control transfers to final destination, the final block can be used to specify any cleanup code, like if you create any objects, and if you want to, if you open any connections, and if you want to close those connections, those statements can be put in finally block. A try finally construct can be used to control the interplay between two actions that must be executed in the correct order. Like if you see here in this example, integer sum is equals to -1, try sum is equals to some number, and finally if sum is greater than or equals to 0, calculate. So if a total is greater than or equals to 0, then only calculate average, otherwise don't calculate average. Like this we can put some set of statements. Let me give an example on a try catch finally. Okay, here we have a class average test, and in this average test we have the main method. Other than main method we have two more methods. One is print average and compute average. Okay, these two are static methods. Public static void print average, which takes two parameters. One is total sum and total number. So it calculates an average of given numbers, like sum by total number. So what we are doing here, we are calling one more method called compute average here, and we are passing the whatever the parameters that has been passed. So total sum and total number we are passing it to compute average, and average here system.out.println average here printing. So here what we did, these two statements we put it in try catch block, try catch, and what we are doing is here through it is catching arithmetic exception, and here we are printing the stack trace, and system.out.println exception handled in print average method and exit of method. So we want to see like how if exception comes, how these statements will be executed. If exception doesn't come, how these statements will be executed. And in public static void int compute average, what we are doing first, we computing average and return some number. So in main method what we are doing is we are calling the print average method, and print average internally calls the compute average method. So first we'll see the positive flow. Print average, we are passing sum as 100 and total number is 20. Run as Java application. See here, so print average, in print average it calls the compute average. So first what it is doing, system.out.println computing average. So computing average. So after that what happened, it returned the average value 100 by 20. Okay, so average is equals to, so it got printed, and here we did not see any errors, so that's why no catch block was executed. If only exception arises, then only it will be executed. Okay, so it didn't execute, and what happened, system out to println exit print average method. So exit, so this statement got printed, and afterwards system out exit exiting main method. Okay, now when this arithmetic exception will be caught, okay, when it will be executed. So what we will do, we will put here as 0. Now run as Java application. See here, first print average, so it goes to the print average method, and it will go to the compute average. So in compute average, what is the first statement, computing average system.out.println, so computing average. And after that what happened, sum by number. So anything divided by 0 will always throw an exception. Okay, divide by 0 exception. So what happened, average is equals to, here we got an exception. So what kind of exception we got, arithmetic exception. So that is the reason average is not printed. If you look at here, do we have the average value? No. So exception handle in print average method. So this statement got executed, exception handled in print average method. Okay, and then exit print average method. Okay, and exiting main method. So whatever print stack trace what we did, that got printed below here. See, so exception is not handled. Suppose if we don't handle this exception, if you don't put it in try catch block, what will happen? Control C. So computing average. Okay, afterwards what should it do? Average. So as we handled this in catch block, that's why we saw exiting main method, exiting print average method. If you don't handle this exception, I mean like arithmetic exception, what will happen? Computing average, exception thrown. We didn't handle the exception. That's why no print statement, printing average method, no main method. See, directly it throws the exception. So if you want to execute any set of instructions like oh, this particular statements may throw an exception, then put it in try catch block. And if you want to execute any of the if exception occurs, what shall we do? So those statements we can put it in catch block, and in finally block if you want to do something. So otherwise what will happen? It terminated entire flow. So even our exiting main method is not executed, and exiting print average method is not executed. So in order to application run smoothly, we need to handle set these application, the exceptions in the application using try catch finally. Okay, next, the throw statement. So in the earlier example, we have seen exception can be thrown explicitly by JVM during the execution. There are the scenarios where we can programmatically throw an exception, like if certain condition occurred, then if we might want to throw an exception, so that we can do through programmatically using this syntax: throw object reference expression. So whatever exception if we wanted to do, that we can throw using throw class. The compiler ensures that object reference expression if throwable class of one of its subclasses. So at runtime a null pointer exception is thrown by JVM if object reference is null. This ensures that throwable will always be propagated. So throw new arithmetic exception integer division by 0. I'll show you how this throw class can be used. So when an exception is thrown, normal execution is suspended. The runtime system provides to find a catch block that can handle the exception. Next, throws class. A throws class can be specified in the header. So if we write any method, okay, and you can specify that this particular method can throws any of these exceptions. So return type, method name, and parameters throws exception type 1 to n. So you can throw that method can throw multiple exceptions. So each exception type declares an exception. Normally only checked exceptions are declared. The compiler enforces that the checked exceptions thrown by a method are limited to those specified in its throws class. Okay, in a method, a checked exception can be thrown directly by using the throw statement or indirectly by calling the other methods that can throw a checked exceptions. So by using a try and catch block, we can handle these exceptions, and we can throw another exception that is either unchecked or declared in throws class. Okay, by explicitly allowing propagation of exception that to its caller by declaring throws class of its method header. I'll explain all these statements. Okay, here we'll use the same class here. So print average 100 0. This now compute average method throws invalid data exception. So what does this invalid data exception class means. So we have created one custom exception, user defined exception, invalid data exception, which extends exception class. Okay, we have already discussed that we can write our own exceptions and put appropriate messages instead of using the existing exception objects. Okay, so what we did here, public one constructor invalid data exception, and here invalid data passed, and there is one more constructor by passing two parameters, integer sum, integer num, system.println sum cannot be divided by number. Okay, so this compute average method throws invalid data exception here, and it is printing computing average and sum here. See here, so one catch block can one try block can have multiple catch statements. So one catch block is executed, then the other catch block will not be handled. So if you look at here, run as Java application here. So first computing average and then exception handle. So first catch block got executed, and exiting print average method, exiting main method. So it is not handled. Okay, now what we will do, we will change something here. Here, if number double equals to 0, throw new invalid data exception sum comma number. So now what we are doing, we are throwing checked exceptions. So it will not be catched here. It will catch invalid exceptions. See here, we will run as Java application. So here, first computing average, next integer number equals to 0. So what it does, 100 throw invalid data exception. So invalid data exception, if we pass parameter some number, what it does, sum cannot be divided by number. So what it did, 100 cannot be divided by 0, and invalid data exception handled, exit print average method, exiting main method. So and invalid data exception got caught. So like this we can use throw and object. So whatever the object we are wanted to throw, and this method is throws invalid data exception. Like this we can use throw class and throws class. Okay, any method that can throw these kind of exceptions, then we can put that exception class name, throws class. Whereas if particular condition occurs, then we can throw explicitly these exceptions. We'll go back to the slides. Assertions. In Java, assertions can be used to document and validate assumptions made about the state of the program and designated locations in the code. So each assertion contains a Boolean expression that is expected to be true when the assertion is executed. If the assumption is false, then JVM throws the special error represented by the assertion class. So if any expression condition is true, then it will return the value. Otherwise, what it does, it will throw in a assertion error class. So the assertion facility uses the exception handling mechanism to propagate the error. So assertion statement, assert Boolean expression. This is the simple form as Boolean expression, and a message what we wanted to print, that we can also put. So evaluate the expression. If it is false, throws an assertion error. Otherwise, it will execution will continue. Okay, if you have any queries on today's session, please mail us at info@bicourses.com. We are happy to answer your queries and questions. Thank you so much.